So the presentation we're going to do now is infrastructure information modelling, virtual design and construct. Now that alone is a massive topic and I've got 20 minutes. Okay, so what I'm going to do is I'm just going to take you through some thought-provoking issues, if you like. So first of all, what is infrastructure information modelling? Okay. And then you've all probably by now, especially if you're in this room, you've probably said, well, hang on, what's this BIM? What is building information modelling and what's infrastructure information modelling? And now, is there a connection between BIM and infrastructure information modelling? You hear lots of these words bounded about. First of all, let's look, is there a definition for BIM? Well, you know, if you go and do the research, you'll find there's loads of definitions for BIM, building information modelling. So, you know, Google's your friend, so go to Wikipedia and have a look. And there it says, well, BIM is a process involving the generation and management of digital representations of physical and functional characteristics of places. Okay, so quite interesting definition. And they carry on and say building information models, which are BIMs, are files, often but not always in proprietary formats and not always containing proprietary data, which can be exchanged or networked to support decision making about a place. Okay. So what we're finding out now then is, well, it's a digital representation of a building process. So therefore it becomes a workflow from the planning and design phase of a project right through the building life cycle, including things like cost management, construction management, project management, facility operation. So we're starting to see that, you know, BIM, if you like, is you know, started off becoming for building information modelling, but in fact it's actually grown. So maybe BIM possibly is the wrong word for what we're looking for in the technology. Again, it's become a generic word and often used as BIM for infrastructure. Okay, so, you know, you're an engineer and you say, okay, where can I go and buy BIM? Right, you know, can I walk into a shop and say, I want to buy some BIM kit? So, well, you can't, unfortunately, walk in and say, can I have some BIM? It doesn't work that way. The reason is because it's a workflow process that's got two key components. And the most important components are people and technology. And that's it. It boils down to two things at the end of the day. So, with all this new stuff coming along, why do we need to change from the traditional way of working on civil engineering projects? Well, the reason probably we need to start changing the way we work is we've got new challenges facing us, not only on the African continent. By 2050, an estimated 70% of the world's population will live in urban areas. The majority of that growth, though, is going to be in the developing world. And if you went to the previous session this morning, there's actually a lot of doubt now that, in fact, whether we should even be building these mega cities. People naturally tend to go towards urban areas. So increasing urbanisation is going to place a lot of stress on infrastructure systems. Because of what we need, we're going to need more investment. China, as an example, okay, plans to reach a total of 85,000 kilometres of expressways by 2020. Now, you know, if you compare that to America, there's only 75,000 kilometres of interstate roads in the USA today. So that's an interesting topic. When I first saw that, I went sort of, wow, that sort of puts a different perspective on things. India plans to complete more than 19 kilometres of highway per day until 2017. Interesting. Right? 18% of the world's population lacks access to safe drinking water. 30% of what's been treated disappears. There's another big issue. An estimated $40 trillion is required to build and repair the the world's infrastructure. So it's an enormous investment worldwide is required. Sustainability. Infrastructure built today is probably going to have a design life of maybe 50 to 100 years, and may possibly also, definitely in fact, will have to meet stricter environmental regulations. You're going to need smart transportation systems, carbon neutral energy production, solar, wind power starting to come in. Smart grid infrastructure support electric vehicles. We can't keep polluting the atmosphere and moaning about climate change if we don't stop the carbon getting into the atmosphere to start with. And so one way is, have more electricity, and of course begs the question, should we keep building coal-fired power stations? Business challenges that are facing everyone probably in this room. Increasing competition, well, we all know that. It's been topic of conversation over yesterday, particularly in some of the sessions. Increased project requirements with decreased budgets. You've got to do more with less. Well, that's a familiar thing, isn't it? The need for consistent and coordinated information. Effective coordination and collaboration amongst your design teams, your project teams, your construction teams. So, can we make things better? Can we think and work smarter? What are the ways in which we can change our workflows? So, what I'm going to do is I'm just going to examine very simply a typical workflow. This actually originated, or the graphics originated from a chap called Patrick McLamey from HOK. But it's a very simple graphic that explains it very well. If you look at the two axes there, the y-axis is the effect or the cost or the effort involved in doing something. And along the x-axis, you've got the sort of various phases of what could be a project, like conceptual design, detailed design, construction documentation, construction itself, and maintenance operations, a typical life cycle. So if we draw one curve on there, this is the ability of an engineer or a designer to impact the cost and performance. So right at the beginning, under conceptual design, the ability of the engineer to impact cost is very good. He's got a high ability to impact the cost. But as you start going down towards construction, over here, then you're going to find that he doesn't actually have a lot of ability. In other words, it's too late to actually make the impact. However, if we look at the cost of design changes, conceptual phase, the cost of design changes is minimal. It's small. You can make lots of changes, it doesn't cost you a lot. As you start getting into detailed design, those changes actually become more costly. And of course, once you get down to the construction site, it becomes a big issue. So if we look at design with traditional workflow, we have a sort of a bell curve, which the maximum effort and cost occurs near construction and documentation. When you've done the detailed design, and now you start trying to knock the drawings out. That is where most of your cost is. However, the approach we take now is probably linear, design, analysis, documentation. That's probably typically probably 80 to 90% of civil engineering consultants throughout the world. Maybe what we should be looking at is more of a model-based approach. And a lot of companies are starting to move this way. There, your design, analysis, and documentation are actually interlaced, they're interacted. Rather than a linear approach, we're more in a model-based, what they call a model-centric approach. So if we plot that on the graph, we can see that what we've done is we shifted the bell curve to the left. So we're looking at detailed design, in fact, is where most of the effort and possibly the cost is going into. But things like construction documentation is actually falling in cost because the documentation is becoming almost like a byproduct of your model. So in other words, it's a model-centric design. So this way, not only are we able to get better projects out because we've looked at more options, but it's actually going to be a cheaper way of doing it and more cost-effective. So let's have a quick recap. Infrastructure information modelling has really been for infrastructure. We know it's a workflow process. And why we need this change is because we've got urbanisation coming up in a big way. We need lots more investment. We need more sustainability, and we've got new business challenges. So those are the drivers to why maybe we want to change the way we work. Big thing again, people and technology. It involves people and technology. And as we'll see later on, why this is very important. Model centricity as well. If you can't change the workflow, if you don't change the way you're going to work, right? Otherwise you'll end up with the same thing that you had before. In addition, new technologies such as cloud-based storage. The first talk we had this morning was about cloud-based technology from Microsoft and how it's actually starting to change the world, the way that people are working. On-demand, massively increased processing power from data centers. So these are the technologies that are coming along while engineers are all busy working on their projects. You've got this other technology coming along and also affecting them. This is obviously going to affect project collaboration, how we're going to work. In the previous presentation by Roger, we're talking about we need the bandwidth and how we're going to do it and how we're going to talk. Like engineer can work in any place, sit in the design office and watch what's happening on the construction site, all about project collaboration. So let's use a very simple example of virtual design and construct and an example of some of the benefits. This is a very simple one. First of all, why would we want to design virtually or digitally? Well, you can explore many more scenarios. It's easier to make changes in the design phase than it is in the construction phase. Much more cost effective to make those changes in the design phase. And you can determine clashes much easier and can be fixed prior to actually getting to site. So you can iron out, if you like, all your design issues before you get to site. Therefore, you would probably start reducing the cost. 4D design, now what's that about? Well, 4 dimension is time. So you've got 3D design, you add time to it, now you've got 4D. It's the ability to design the constructability of a project or phases of a project prior to the commencement of the construction. So sort it all out digitally before you actually get to site. What if scenarios can then be tested easily as well? 5D design, is that possible? Yeah, we can just add the costing. So now we've got the 5th dimension being cost. Ability to match resources to the constructability plan. Ability to determine potential cost savings. So as an example now, and this is an extremely simple example, because what we've got here is a design maybe for a rail over road scenario. Okay, we've got a Eskom pylon and we've got a couple of minor electricity distribution posts there as well. So what we can do with it, because we've got a 3D model, and the thing about this is the information can be gleaned from lots of sources, not just from one source, from lots of sources by collaborating. So of course, yes, we can do things like turn the model around, and we can, all those good things as well. But we can actually also look at the interaction between various components, and not necessarily did you design them all. We're collaborating better. But of course you can start going underneath and having a look at what's going underneath, which is probably where the problems start, the below ground. So here you can see we've got piles, we've got pile caps, we've got a bridge deck, we've got pipes. So you don't want to start driving piles through where there are existing pipes. So this just gives you a very simple idea, is if you work in terms of a model, you can work much more effectively with the engineer. As I mentioned, this is a very simple little example. You can imagine if you were, say, in the London Underground and you were going to put through a new tube, and just imagine the millions of services that are already there. To a design engineer, it's a nightmare. If you can start modelling it, then you can be able to find out all the problems before you get to site, before you break the gas mains and things like that. So let's have a look at virtual construction. Now, what we're going to do here is apply a timeline to the construction phases to help determine the constructability plan. Again, back to our little model as an idea. So here we're going to say, well, if we were trying to build this, we should pull the contractor in at design time and say to him, this is what we're going to build. Now we need to sequence this to make sure that we're building it in the most optimal way and we don't involve extra construction charges later in the game, because we didn't know that that was going to clash with this, or we've got a problem getting some equipment in, etc. So again, on the timeline, if you watch the screen carefully, you'll see some pipes going in, existing terrain going in. That's what you start with. Then we're going to do the finished terrain, the ground, if you like, after the major earthworks. The road goes in, it starts getting built. Then the pipes go in. Now we can see we've got some piling going in, and then we start building the bridge deck and the parapets. So you can do this over time. It's like a slider. You just say, okay, what do you want to build when? And you can also apply resources to it. And in goes the pylon, and in goes the distribution lines. So just from the same model. But the model could have been, parts of that model could have been built by different people. This is where the collaboration comes in. So what's happening in other parts of the world? Okay, so you say we've got all this stuff. It's all possible because you just showed that. But you know, what are others doing? Well, lots of countries, and this is not an exhaustive list. Okay, UK, Europe, America, Singapore, Australia. They're all getting, if you like, into this new way of working. In the UK, for example, I'm using that as an example because they're probably at the moment one of the most advanced in the way the government has taken responsibility. So the government there, published by the Cabinet Office on the 31st of May, have a government construction strategy. And the report announced the government's intention to require that collaborative 3D BIM being a generic term, with all project and asset information, documentation and data, it has to be electronic, will only be used on all of its projects that it gives out by 2016. So they're basically saying, if you don't change the way you're going to work, you won't get work from us. Which is quite a bold move from the government. And of course, the reason they did this is because they looked around all their public assets, public sector assets, and they said, we want to get a 20% saving by 2016. And they did a study and they saw how much time and energy was being wasted as people were working not collaboratively and not using modern technology. Useful links. One of the most useful links I found there is you go to the bimtaskgroup.org. That's a very useful link if you're interested in learning more about this. ICE.org as well, American Society of Engineers, and publicly available specifications, which are really precursors to BSI. They're actually starting to say this is the way you must work. So they've really sort of taken the bull by the horns and gone for it. What's happening in Africa? Interesting. South Africa, East Africa, West Africa. But as far as I'm aware, I don't know of any government in Africa that's actually started to say we need to start changing the way we work. I'll leave you with some concluding thoughts. Shall we just ignore it and just say, never mind what they do, we'll just continue status quo? We could do that. Or shall we adopt new workflows into our engineering? I'm going to leave you with these thoughts. In fact, they're not mine. They're from a chap called Scott Zimmerman, who's the manager of enterprise systems in Bechtel, and he has these thoughts. Your teammates and fellow colleagues probably recognise the challenges you face each day. Yet, changing to a new way of working and communicating can be difficult, especially when people are in the midst of fast-paced, complex projects, which is almost always the case. And we all know that scenario. I'm too busy to learn something new, and that's just so common, and it's a reality of life. It also requires a cultural shift, because moving successfully and using things like the cloud requires thinking in a more collaborative way. Your employees will have new and easier ways to share information, work together with colleagues and subcontractors, and work quickly to solve problems. Even when team members are working remotely, possibly even on the other side of the world. And finally, the cloud is about people, process and procedure. If you're going to have a problem, it's going to be with the people. I think a lot of people are starting to realise this. I see some smiles in the audience. The change in process and procedure has to be communicated, and most importantly, has to be tailored to your business. So the people aspect is often, do we want to change? Yes, we do. But you've also got to get the buy-in from your teams in order to make that change.